Hey everybody, this is Larry. This is day 28 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. I don't know why I'm dancing. I did take a nap though, so that feels good. Yeah. All right, let's see. Today we have 3651 minimum cost paths with teleportations. All right, well, it's a hard problem, so it's going to be a little bit tricky. And not only that, it's a hard problem, it's a recent hard problem, if you will. So we'll see. These problems are always a little bit awkward for me in that because they're recent. I already have a recent video out, right? Like I do them. I don't. Actually, let's take a look. Okay, yeah, it's still in August, so because I was going to say usually I do it right after the contest or during the contest, right? But of course, those of you who've been following, last 2 months I've been traveling, so I've been kind of backlogged. I finished them all, but they're just not as up to date, if you will. But my point is just that we've had a recent video on this, so I don't know. Let me know what you think in the comments. But in terms of difficulty, it also just means that it's more difficult than say hard problems from earlier on. So we'll see how it goes. It's still very cold here in New York and stuff like this. So yeah. So I'm kind of, I don't know, just very cold. And I think where I'm sitting in the kitchen there's like a leak somewhere, so it's a little bit colder than everywhere else. So I guess we'll see how long I could go because I just go back to the living room. But okay. Is there anything more? No. Yeah, so everybody, yeah, that's it. Oh yeah, one last thing. That's what I forgot. I was like, something is bothering me. But yeah, I don't know if this is a big number, but I just hit 70,000 subscribers here on the tubes. Probably 75,000 is a more round number, but I don't know. Right? It doesn't really matter that much. But it doesn't matter to me per se because number is just a number. But for every one of you who is watching right now, thank you for continuing to watch it. I think my content is always a little bit weird because it's not, this is meant to be live. This is meant to, you see me struggle sometimes and stuff like this. And hopefully we both learn and stuff, right? So it's not meant to be, like you can't watch every one of my videos, and it's not every one of my videos is applicable to everybody anyway, right? So it's kind of hard for me to, know who's watching. And I just think about it more. I know these are videos and you can go back to watch older videos, and I try to make them, future proof, right? But in a sense that given a problem, nothing's going to change about it in the future. Usually, sometimes they go change the problem a little bit, but usually nothing changes about it in the future. But with that said, my style, if it's not clear to you, is that this is more like a live stream type thing. So I don't know. We'll see how it goes. But a good amount of y'all still kind of tune in every day, right? So thankful for that. Hopefully, my life gets more exciting so that I don't know, so that it's just a little bit more interesting on top of these things. Also, my camera broke when I was in Paraguay, so I've been kind of still upset about it. And I have to fix it somehow, but they're charging me an arm and a leg DJI, so I think it's because of this China whatchamacallit, import tax or export tax. Well, export from China tax. I don't know. There's a tariff, and it's giving me issues with my camera. All right, enough of rambling, enough of ranting. Let's take a look at today's farm. We have 3651 minimum cost paths of teleportation. You have an R by C grid, integer K. You start upper left. You want to go to bottom right. Okay, everything's so good so far. Normal move. You can move right or down. I don't know why I drew my fingers wrong, but right or down, and this may not be mirrored, so it may look wrong anyway, but down should be not mirrored, right? Okay. The cost is the value of the destination cell. Fair enough. Teleportation. You can teleport from any cell ij to any cell xy such that grid xy is less than ij. The cost of this move is 0 as long as it's smaller, right? Okay. So I see. I don't know that this is a class of problem per se, right? But I do have like an idea about these things because similar things has come up, right? And I think this is something that that you just work on over time, you know? Because I think for me, you know, we talk about pattern matching a lot and stuff like this and how I'm not a fan of it. But that said, you know, you're given a certain problems a couple of times and you kind of see the idea and patterns and playing around with it, right? And without looking at the constraints, I'm just going to guess that R and C is big because, well, if R and C is not big, this is just very not interesting and it shouldn't be a hard because you could just do a regular BFS or something, right? Or actually, in this case, it's Dytra because of the cost, but you get the idea. And R times C is big, right? Because that's like 6,400, right? Is it? Can I do math? Yeah, 6,400, right? Which is, you know, and you cannot do 6,400 square. That's the biggest thing. And when you see kind of like this relationship, you immediately jumps into, well, you know, the normal move, you can only go down and right. So each cell has two edges, right? But here, immediately, you already can have O of n edges. N is equal to R times C, by the way, when I say n. And when you have n edges, and with each node can have n edges, I know that it's like a what's it called, triangle numbers thing, right? Or Pascal triangle numbers, right? You have 1 plus 2 plus 3 plus 4, but that's going to be n squared, right? Because you have average of n over 2. Anyway, and you know, when you just do the math real quickly, it's going to be n squared and it's going to be too slow. But also, honestly, I knew that there was going to be a trick, or not trick, but there's going to be a tough portion, right? Because otherwise, like I said, if we just put everything in a Dijkstra, this is not a hard problem, right? Though I guess we said that yesterday, and yesterday was, no, yesterday was medium, right? That was the one with the reverse edge thing. I don't know. All right, right? So the idea here is that, and this is something that I came up with, right? And I don't want to, maybe that's quite the wrong phrasing. I don't want to say I came up with, like I invented it, but I just mean that, like, you know, I noticed this idea, and then I noticed this idea again when we did similar problems, like they give another problem that's similar, and then a third problem, right? Which is this idea that, and this is something that I came up with, right? As in, I don't mean, like I said, I don't mean to say that I came up with, like I invented it, but I just mean that I didn't read it from anywhere, right? Like I just, you know, so, and I say it like that not to be like, oh, I came up with it because I'm smart, but I just want, but why I say it like that is just because, in a sense, like I'm trying to talk about not necessarily, you know, how to solve these problems, but or how not to solve this problem, but able to learn how to solve all problems that are like this, right? So that's why I talk about it like this, right? Like I don't, like one problem, like I don't really care about it per se, but I you know, once you learn the ideas and play around the ideas and observations, then and you should be able to attack similar problems, right? And maybe even build on top to do harder problems that are harder than this one that needs this as a prerequisite almost, right? And yeah, like I said, the way that I say it, the reason why I say it like that is not, you know, trying to be like, oh, I'm a genius. I came up with this by myself, right? No. But what I mean is that, like, if I could do it, most people could do it. I mean, maybe it takes practice and a lot of fundamentals or whatever. And keeping in mind that I say it as someone who has, at this point, legitimately, what year is this? 2026. Legitimately 21 years of experience, or more than that, really, but at least 21. And I say 21 because I'm an American, and it just means that if I had a kid when I started competitive programming, that kid can drink and drive now. Not at the same time, hopefully. I don't know why I said it like that. But anyway, my point is that I've been doing this for many, many years, right? So, you know, it's not, like I want you to set realistic expectations. And look, a lot of people could be better than me eventually, but I'm also just giving you my, you know, like this is how long it took me, right? I mean, obviously I'm not like making progress over 20 years, right? I worked hard in the beginning to learn, and a lot of this is like maintenance work, if you want to call it that. But you know, but I have a lot of muscle memory and this idea, right? And this is why I phrased everything this way. This idea that I quote unquote came up with, it's more recent. It's something that like I don't think I quote unquote learn. It's something that I noticed from a couple of problems and try to come up with it. And the first time I did it, I probably took a long time. And I was just like, oh, you can do this. And then the next time, I'm like, oh, you can do this. And then now I'm like, oh yeah, of course you can do this, right? And what I mean by that is just this idea that, you know, and we can maybe start by doing some drawing. So let me bring up the drawing board real quick. Right? Because the key part about this problem is try to avoid n squared, right? And n, as I say, is r times c. So when I say n squared, I mean r squared times c squared, if you want to say it that way. And this is this idea that that, you know, again, this is a shortest path thing. I mean, I know this is a grid, but it doesn't matter, right? This is still a graph in some way. Oops. Actually, maybe I shouldn't make this confusing. Let's go back. So okay, so we have a grid, right? And each node, like I said, normally would have two edges, right? But then now it can also go to the what? So we're here, it can go to x, y, in which it is smaller. So maybe you can say that it has like random jumps to just, you know, different places, right? You know, you know, so forth. And again, you know, I mean, a very simple, I used a different blue, but whatever. A simple, you know, example is that you have the biggest number here, then now you're drawing an arrow everywhere, right? The core idea about these problems, and it may not apply for every one of these, but then it would just be really impossible. So maybe it has to if it comes to that, is that you're trying to reduce this from n squared to at least not n squared. But the core part about this is that shortest path, right? And I urge you at this point, maybe I should have mentioned it earlier, but I didn't really think about how I wanted to talk about this because everything's new to me, right? Is watch yesterday's video. And what I mean by that is, yeah, I go over a lot about the ideas for this thing called shortest path spanning tree, and this idea that built on each other where like you have this component, right, and stuff like that, right? So watch it because this may not make sense because this video is going to be an extension of that video a little bit, and it may not make sense if you're watching it out of context. But what I want to say is that, okay, well, you have this shortest path frontier, even maybe that's a better word, because yesterday I said component, but let's say you have this shortest path frontier, you have this frontier, right? And then now, because everything is cost zero in this particular case, you might visit this one, this one, this one, and this one, and this one, right? And that's fine, right? But then what you want to avoid is not necessarily visiting this for the first time, but that, let's say, you know, now the next, this wouldn't make sense because these are zero cost, so you probably actually want to call, all right, fine. Let's say that because it's zero cost, you do this one next, right? As part of your frontier. And then now what you want to avoid is just going from here to here, to here, to here, to here, to here. Why? Because you know that we already went from here to here. Let me change colors again. You know that we already went from here to, here to here, so then why are you, so here to here doesn't make sense. It's not going to give you a bigger move, right? So this is the core idea about it, and after that it becomes implementation. But the core idea is that you don't want to do these duplicate edges, and that you only visited one of these frontier once. Not you. So there are two things, right? You don't want to not only, because I mean, the more, even Dijkstra does this anyway, right, is that here you only relax this node once. But for this problem and similar problems like this, it's not just the relaxation and adding things to the queue or even checking things on the queue, is that we don't even bother checking these into the thing, right? So that's basically the idea behind this, right? Is that we don't even check this edge, because even though this may be connected to all these, we don't even look at it, because even if you just do a for loop to check, it's going to be O of n, right? So you want to skip checking altogether. And there are different ideas about this, and I don't know how I did it last time, to be honest. Is because I think the thing that I always say is that the idea is the hard part, right? Once you have this idea, the implementation just tests how accurate and how clear you understand your ideas, right? Because if your idea is a little bit off, then then you may not able to handle off by ones because you're like, well, I didn't think about my idea is not clear enough to handle this off by one or something, right? So after this, it's just this idea that we don't want to reuse these. Not that we don't want to reuse these edges, we don't even consider the existence of these edges, right? And that's basically the idea. For this particular problem, the first thing that I would notice is that, well, if we have this, that means that you have this like, actually let me bring back the, well, yeah, but look at what I, the other side. Look at what, it's mirrored, it's weird. But look at where I highlight, right? So noticing this thing, because I'm going to bring back to drawing again. Then now you have this idea of, okay, now instead of this, you have these nodes, right? Because now let's say you sort these nodes in decreasing order, then because if you sort these in decreasing order, then you have these nodes. And then another way of saying it is that if you're here, then you could visit everything to the right, right? And if you're here, you could visit everything to the right. If you're here, you could visit everything to the right. You get the idea, right? So the first thing that I notice would be that, well, now I sort it so that I get this structure. And then now, as I process this going from left to right, I just remove them from the future, right? So that let's say, actually, I mean, okay, actually, let's just keep it this way, but I'll use another color. So let's say that your first node is actually here, right? Then now we can process these, of course, because we want to, but then now we remove these and this from consideration so that when we want to say, okay, now we're considering this node, then now we want to consider everything from left to right, then we only consider these two nodes because we know that we've already done these. And that's kind of, once you're able to see kind of these structures together, then you're able to fit everything together, right? And that's kind of the core part about this. My Duolingo is telling me to do my Duolingo. So, well, I mean, I still have an hour, so it should be okay, but sometimes I just forget. But yeah, so then now maybe I would have something like right, to kind of create that sorted list. So then maybe I would write maybe just a sorted list, just because I'm lazy. I mean, you probably could do this with like did we do I think we did a doubly linked list either 2 days ago or something. I don't remember the problem. But there was a there was a doubly linked list problem, right? Maybe during the contest problem. But either ways, so you can do this with a doubly linked list as well, because now you have the node, you can just get rid of everything below, but you still need to sort anyway once. So I don't know, maybe I mean the doubly linked list things will be fast for sure. But I'm not doing it because it's more annoying. Maybe we'll have to, and when we do, then we'll consider it again. But for now, we'll just do it this way, right? I mean, yeah, right? Yeah. I mean, yes, but actually it has to be a little bit cleaner than this. Maybe not a sorted list then, right? How do I want to write this? Because the reason why I'm like is because if you have like it matters, like if you have like a value like I don't know, 5, like the good value is 5, 0, 0, 5, 1, 1, 5, 2, 2, meaning that this value, the good value, is the same. And let's say you process this one, but you kind of do what I said about going from left to right. If you're going from left to right, then you may miss, if you're going from left to right and you only hit this next, then you might miss this one, right? So that's what I'm thinking about in my head. There are probably ways to handle this. I'm trying to think what's the cleanest way. Like the idea that I would have maybe is just put everything in a map or something as well. And then just consider the distinct values. Maybe I'll do it that way instead. Maybe that's a little bit cleaner. So then you have like, let's just say items is a terrible name, but then you have a default dict of a list, and then maybe you have just like a sorted yeah, maybe a sorted set, right? And so then now, as you can see, I didn't really have the entire idea in my head with respect to implementation, but I have the right idea and I know it. it serves as a North Star for how I attack this implementation as I notice things, right? But here we just have, okay, just the indexes of items sorted, the unused ones, right? So then now we can maybe write something like items of grid of xy. We could now add xy, right? Something like that. And that's basic. Oh, and ss dot add grid xy, because we have to consider it. And this is a set, so it should be fine. And then yeah, then that's it. And then everything is just, well, not just, but a lot of it's gonna be called like Dijkstra. So we set up the Dijkstra. I don't know where it is. I guess this is fine, right? Yeah, and then we set up, you know, is equal to 0, I want to say. Do you count the initial cell? Doesn't seem like it. I just want to make sure, because I don't know. It's used to misread stuff like this. So, what is K? Oh, K is the, oh, you may teleport at most K times. So actually, I missed this. But I mean, it doesn't change it that much. It just adds a dimension on the teleportation. But I actually did miss this though. So then now we just have to add. Yeah, I mean, actually, all the other graphs should be, everything I said should still be the same. It just adds a little bit of a wrinkle. So okay, so I just say I like big K. Whatever. There's some nuances that I'm thinking about, because technically, if you really want to optimize, you actually want to know, because this is probably in the weeds. You should worry about solving it first, but there is some optimization about the ordering of R, C, and K. I'm not gonna go over it for this one, and I'm just gonna pretend that it doesn't exist for this one. But it is something that I think about. But I think that's a premature optimization, so that's why I was like, it should be fine, right? So 0, 0, 0, 0, right? So then we want to say, I guess it doesn't really matter, but it's just distance xy k, right? And then now this is, relatively speaking, straightforward. CK for current K. Relatively speaking, straightforward Dijkstra. And then here we do the normal one, right? First, normal, was it write down? So then we have, yeah, maybe you can write this in, you don't have to write it this way, but I will, right? So then now if distance of D, there's also some optimization about K, by the way, though I don't know if we need it, because yeah, it just prevents certain things. I'm not going to talk about it that much, actually. Also, I forgot we have to do the thing, right? So if distance of x, y, c, k is not equal to D or greater or less than D, then we just skip, right? If the distance, why is D there? Nx and, oh, I'm kind of writing this in a dumb way. Because K doesn't go up. If this number is bigger than distance of x, y, c, k plus grid of nx and y, right? Then now this is just a regular in Q. Maybe I should have it in Q helper, but it's fine. And then right. What is the new distance? We just have. Right, and that's it for the normal write down. And then now you have to do all the craziness of teleportation, right? And yeah, so there are a couple of things we can do, right? And it's just we find the sorted set. I guess I mean, there are a couple of ways you can write about it, but I think we can just do something like this. And I mean, there are a couple of ways you can do like a binary search or whatever. But the idea that I'm thinking of right now is just that we could treat it like a heap, actually, right? And maybe we could actually, now that I think about it, just treat it, just actually have a heap, but it's fine. But which is that, for example, if you have 5 as the current value, as the current grid value, if 5 is the current grid value, then you just kind of you just pop off the heap until you hit 5, right? So while this is the case, and SS of 0 is less than or equal to grid of XY, the current cell, right? Then we have SS of 0. Okay, so then now we have key is equal to this thing, SS dot remove key, but then we actually store the thing in this thing, right, in items. So items key is going to give us XY, right? So for and this is the maybe NY, NX, NY. We don't have to do our bounds thing, presumably, but we still have to do if distance NX, NY, CK plus 1, because we're moving 1, right? We're using 1 teleportation, that's wrong. CK plus, oh, I guess this is just plus 0, right? So it's going, if this is the case, I think one thing I would say is that it is key that k is equal to 10, because you probably could just loop back and forth on the k. I don't, like I said, I don't know if I'm gonna, I worry about optimizing for it. For now, maybe we should, but it's fine, right? Like if it gives me a thing, I'm gonna blame Leetcode, but I'll fix it. And that should be it. Because after we process this, we remove the key, so then none of the teleportation should hit that up again. Yeah, and then now we can actually here we should return -1, which I guess is not a thing, but here is the first time we're relaxing it, right? So if x is equal to or minus 1 and y is equal to c minus 1 and that's it, right? What am I ending? We return d. Hopefully that should be good. Looks okay. I mean, texture stuff is gonna be okay. I do worry about like silly mistakes here, because that only comes out not in correctness but in TLE, right? If you forgot to remove the key, for example, you'll still be correct, but it'll be TLE. So let's YOLO submit though, because I'm lazy, and we'll see. Oh, I mean, this is just a dumb mistake. Did I make this turn in contest? I did not, but that's just dumb. It's because I forgot this K. So here maybe we use teleportation only if CK plus 1 is less than or equal to K, and we should be good. And we allocate the space for this. It's just that I forgot. It happens. Like I said, I don't know. I mean, I've been talking for half an hour, so I'm like a little bit lazy. Like I get a little bit like just want to end this, not in a deathly kind of way, just like, get this done. Oh no, this I did not expect, honestly. I did not worry about correctness, but maybe I do have an off by 1 somewhere. Huh. I mean, the annoying thing is that this is like very hard to debug or like visually debug. Huh. 2 teleportations. Oh, I see, I see. I actually was thinking about this as I was writing this. Yeah, because I spent so much time talking about teleportation, I kind of just grazed over it and I didn't really rethink it because a lot of it is because I am on this video, right? And I did see this, or I didn't see it because if I did, I would just have fixed it. But I was thinking about like, is this going to mess it up? But I was like, yeah, let's just YOLO, which is this part, right? It's not this part related, but when I wrote this part out, I was like, that may be weird. And the idea is that for every K, we need to, because, okay, let's actually bring back the thing, right? The drawing thing for a second. And this is a silly mistake. I mean, it is an easy fix, but I just want to explain it. The idea here is that we have this thing. The idea that I was saying is that we have this thing, right? And at this point, remember that I forgot about the K. I just didn't remember. That we can, or that I thought you could do unlimited, so I just didn't notice it, right? Is that we can like maybe do this one and then we just kind of cross it out, right? But the thing is that, you know, like maybe it makes sense to do it in a different order, for example, right? So what I want to say is that this only holds for a certain K, because you have a different K, then you may want to go to a cell that is, we want to visit with, so that, it gives you another function, right? For example, you may imagine, I don't know what's the case, but I think that is the idea though. Because I did realize that maybe there's an edge case there that I didn't consider. But luckily it's easy to fix. Maybe we just have this. I don't know, maybe it's K. And then here, maybe we just have K in range of K plus 1. Right? And then now we just add this, and that should be good, but well, I mean, maybe if I didn't have indent error 71, where's line 71? Huh? Oh, I thought it said 71. But also, that's such an obvious indent error. Cannot use. Oh, of course. Huh? Oh, I see. Whoops. Yeah, I mean, but I would say, so the reason why and maybe this times out anyway, so we'll see, hopefully not. Maybe it does, then we have to add some optimization. But what I was going to say is that, as you can see, the reason, oh, okay. The reason why I am able to kind of debug it, I mean, this maybe, I don't know if I expected it, but I was just hoping that I would. But I was able to debug so fast is because a lot of it is just experience and like feeling the texture of things. I don't really have like I don't wait for a strict proof, right? But that is sometimes, that is just what it is. You just have to practice a lot to kind of notice, like, because this is essentially, this is a greedy problem, right? And there's just a lot of ways greedy problems pop up. The reason why this is kind of time out is, and I kind of knew this was a possibility, but I was hoping that in aggregate, oh man, I can't say words anymore, that would be fast enough, but apparently it's not. But the idea here is that it visits a lot of stuff where like it just goes back and forth, right? So maybe it goes to this node, but then it goes back to the same node, and then same node, it teleport, because the teleport cost is 0, it may teleport back and forth 10 times before, so that's why, so then now we don't want to do that, right? So then what happens? There are a couple of ways you can handle this, really. We can the lazy way, maybe we could just set it this way, where if this is the case, then we also set all future things, right? So here maybe go mk for maybe k. I don't know, that's just terrible, right? But from range from ck plus 1 to k plus 1 inclusive, then now maybe just do this, right? And then the reason why I do it this way is then now this will never be true for any of the bigger k's at the cost of a loop. And this loop may look expensive and it's not cheap, but at least you're not doing this heap for all those elements again, especially this step again, right? So there's some relaxing there. We can actually add this here. I don't know if it does show up or not. I guess we should probably, so this is like 63 millisecond. Without this, we can actually, well, we could just do, I don't know, just this way. So just to see how long this would be. I don't know if this is meaningful, to be honest, but it should be meaningful over the hardest sets, right? So this seems consistent. But yeah, and this is just a hack. Another hack that you can do is maybe like clean up, like maybe do something like here if we want to. Hopefully this is fast enough to pass. How did I get it to pass in the contest? Okay, I did get it past, even though it went over 10 seconds. But yeah, these are things that, I mean, I kind of alluded to this idea, or not even this idea, but the idea that we have to do something like this in the future. But I was just like, hopefully I don't have to. How did I do last time? Oh, and I even made an optimization to go to 5. How did I do that? Oh, I mean, yeah, instead of doing it this way, you could probably just have written, you could probably keep track of the last CK that you use, right? Is that what I did in the past? I mean, this is basically what I did now, except I count downwards last time. Oh, and I used a queue instead of a sorted set, but I did have CK in there because at that time I did remember, I suppose. Oh, and I just, oh, I see. Oh, I did use a queue, but I didn't use it in this weird way. So maybe that makes it a little bit faster. How do I make it half as fast? Oh no, I guess it is just faster because I wasn't using sorted, like maybe I didn't do this, that's why it was faster. I see what I did here with the queue though. It's the same idea that I did here, to be honest. So maybe it would have been the same. But I was thinking, because initially what I was thinking was in the original way was that I was going to binary search and then just look at everything on the left. But if I thought about it as a queue, then it would have made more sense. I don't know. But yeah, this is, as you can see, a tricky problem. I mean, I went over a lot of the math and the foundations about this, because otherwise, honestly, for me, I probably would have solved this in, I don't know, 10 minutes, maybe with debugging and fixing 15 minutes. But this is a very long video because I want to go over all the fundamentals, all the ideas that hopefully, you take it with you in the future, right? But that's it. That's all I have for this one. And I got 3 wrong answers today instead. I mean, in contest mode, Larry is more focused, I think, and I don't get distracted. I mean, not that I get distracted. It's just that like it's almost like the way that I think about it is that my memory has like a cache of sort, but because I'm talking, it just kind of like pops out of cache, or like, my memory got directed because I'm talking about stuff, and it slows me down a lot. Where normally I'm like faster, so that I'm like, oh, I have to do this, and I just do it instead of like, oh, I have to remember to do this, but I'm going to talk about this other thing first because that's what I'm doing now. So yeah, video Larry is definitely worse, but it is what it is. Or explanation Larry, I don't know. But that's it. That's all I have for this one. Let me know what you think. Thanks for watching, and yeah, let me look at the code for you one more time. But yeah, as you can see, I mean, like I said though in the beginning, or near the beginning, maybe not the beginning anymore, is that once you have the idea, the implementation is, like I implement this a totally different way from last time. I mean, okay, and then it had some performance issues as a result, but correctness it was not, right? So I don't know, it is what it is. But yeah, that's it. That's all I have for this one. Let me know what you think. Thanks for watching, And yeah, stay good, stay healthy, to good mental health. Maybe stay warm if you're cold. Stay cold if you're warm. Yeah, whatever. Stay cool. I'll see y'all later and take care. Bye bye.